All right, good afternoon. My name is Provalov. I work at Netflix. Today I'll be sharing our experience with taking Netflix global with search. If anybody needs to come up with a presentation name that is not too short, just let me know. I can help you. I'll start by talking about our use case a little bit, and then we'll get into configuration, not too much detail, but just to give you an idea like what kind of Solr configuration we're using. And I'll talk about scoring because that's an important part of this. And then I wanted to jump into some of the language challenges we've seen in the last couple of years, and then talk about this custom component we've open sourced. It's actually a patch right now, a character mapper. And then I'll talk about another open source component that we used, a query testing framework that we also open sourced. So this year we've launched globally. We're in 190 countries right now, and we support 23 languages, which means we go, the devices have to support all the localization strings, the keyboards. There's also a large component in the content that we have to support. And of course, the search itself has to be supporting those languages right now. In our use case, of course, it's searching for like titles, genres, people. This is our web UI. This is query suggestion section on the top here, and then in the middle section, normally you have titles that we found. And typically, like genre, people-related stuff in the web UI would go in this top section. Depending on the device, it may be in a different section. Okay. So our use case is very short fields that we search. So each entity that we search, it's pretty normally distributed. There's no super long names. They're all fairly short to medium size, but specifically title names. Okay. Shorter documents have to be ranked higher, so that's another interesting aspect. And then it's, of course, autocomplete, right, type ahead. So with the first character, we start returning results. And then for, typically, we prefer recall over precision for our lexical matching that we do in Solr. And then the click models will correct for that pretty quickly. So we're currently using Solr 4.6.1. We're in the process of migrating to 5.5.2. And I would like to just briefly describe these three things that I think are pertinent to our discussion. We're using EDismax or EDismax query parser. It does provide nice functionality for like boosting pretty simple syntax, and then the max field score, which I put here twice, is something that we really need. So that means like if you have a document with multiple titles, let's say you have title in English, and then some alias title, and then an AKA, we want to make sure like if there's ambiguity, if two titles match, the max score will be actually returned, right? So that's where the EDismax is useful. Then we're using the phrase queries, and the reason for that is like EDismax has a little quirk that it actually goes and searches across the fields in a multi-term query. And to prevent that from doing this, you can actually provide the phrase query, and then it will limit itself to a single field at a time. And then the Ngram is like really the core of the autocomplete, right? It's the basis for the autocomplete. If you are not familiar with the Ngram filter, it's basically, so this is like index time, tokens, taking Breaking Bad and splitting them into character Ngrams, okay? The one interesting thing here is that it produces the tokens for each of the original, or produces the Ngrams for each of the original tokens in the same position. So breaking will be emitted with position 0, so BBR, it's all in the position 0. And then the second token, bad, will be emitted in the position, all of the Ngrams are emitted in the position 1, okay? And I'll talk about that, like why this is important. So The scoring part of the autocomplete is also interesting because you have short fields. You may have some skewed data. Let's say you have your alias field that is only populated sparsely, but your like main, for example, if your main language is English, your English field is populated in 100% of documents. If you do have that, the TF-IDF similarity scoring may be producing some scores that are not really optimal for your case. The reason for that is like the document frequency may actually boost the documents that are that have sparse values in some weird fields that you didn't expect. So what we when we looked at that, we decided to remove the document frequency from the scoring component. The second thing is that the TF-IDF similarity out of the box does this document length normalization. And what it does, I'll just go to the previous slide. So if it sees the tokens emitted in the same position, like in position 0, it will actually discard them. It will not count them towards the document length. And it's important for us because we want to make sure we rank the shorter documents higher. And so like what we're using is essentially just a bag of words unigram language model where it's term frequency over the terms in the document. And to make sure that the terms are counted as number of characters, we actually have to remove the document normalization. So in essence, this is like very simple scoring where it's just a term frequency over the number of terms in the document, which is essentially a document length. And then we take a log of that to avoid the underflow errors. And then we actually get negative score in the end, right? An interesting quirk about the negative score is that it stopped working in Solr 5.5.2, and that's what I've been investigating recently. And the reason for that, there was a value that was initialized to 0, so like anything below 0 would not even make into the scoring. And the fix for that is already in, I think, 6x was put in last week. But it does work fine in 4.6.1. So some of the, just a high-level overview of some of the challenges that we've seen in the last couple of years, and then I'll jump into a couple of these cases, and then I'll start talking about some of the components that we use to address these. Japanese, for example, uses multiple scripts. And you can have a title that actually has a mixture of like kanji and hiragana or kanji and katakana. And in some cases, actually 3 scripts. There is no token delimiters in Japanese and Chinese, so like, you know, your regular tokenizer is not going to work, but there are some good options in Solr, like Romaji. Korean has this character composition where if you have autocomplete and user is typing characters one at a time, right? They will be typing like very small parts of the actual syllable. And unless you can manage that, you're essentially not going to get results. And then stop words is another interesting case. Like with regular search, you know, stop words just work as expected. Like, you know, you're just stopping some terms. But with the autocomplete, you may be typing 3 characters, and the 4th character becomes some stop word, and your results disappear, right? So you just have to be watching for that. And then a lot of languages that we've recently started supporting have definitely need for stemming because of some morphological variations. So here's an example of Korean character composition. As user types these characters, character sequence, once the 3rd character is typed, it actually becomes decomposed JAMO character. And then once the 4th character is typed, it actually becomes fully composed Hangul character, which are completely different Unicode characters. So if unless you're mapping it behind the scenes and you can actually create like a baseline decomposed version of them, you may be getting some like empty results page on each keystroke. So unexpected behavior. For Japanese, this is the example of like mixed script. This is not mixed, actually not mixed in the title itself. This is multiple script. But let's say you have Antarctic story, the like Romaji tokenizer will do a good job, split it into two separate words, and then actually it will produce the reading form for you, which is Katakana. And then if query is in Katakana, it will match, but if it's in Hiragana, it will not match. So there's some additional work that needs to be done, like transliteration and so on. So ICU, for example, is a really good source for doing these kind of normalizations, post-processing after the Romaji analyzer completes the pipeline. So when I talk about the pipeline, is like these tokenization pipelines are very well documented in Solr. There are three parts to it. There's char filter, which preprocesses input characters. It doesn't really care what the tokens are, what the words are, right? It's just like removing special characters, doing that kind of stuff. Then there's tokenizer, which is like the core thing that makes your blob of text, splits it into the actual words or tokens. And then there's filters that will transform, create new, remove. You have a lot of flexibility there. So here's a simple example that I thought just for demonstration purposes, it has all three components, the character filters, tokenizer, and filters. At index time, it just does this simple replacement of, it drops ing, essentially, at the end of the word, and then standard tokenizer, and then lowercase filter, and then edge Ngram filter factory. I just put the edge Ngram filter there. It kind of like demonstrates how the Ngrams work in the Solr UI. And at query time, it's exactly the same thing, except you don't really need to use the Ngram, right? Because for the autocomplete, as user types, you already have those matching tokens. So like this is what the Solr UI would look like. The filter, the query is going versus index value is go. So the first step basically chops off the ing. Everything else stays the same. And here's the interesting part is the very last step will tokenize go into G and GO, emitted in the same position. So some of the corner cases that we've run into made us build this custom component, which is a character mapping filter, which doesn't happen on pre-tokenization, but it actually happens on post-tokenization. So what it allows us to do is actually allowing us to do more custom morphological work. Like we can do prefix removal, suffix removal, or modification. So that component can actually tell or can actually modify part of the token depending on like which position you tell it to do it. So there's a lot of cases where you want to do it only like at the end of the word, only at index time, for example, because the autocomplete is kind of different animal. And then we also use that for character decomposition. So for Korean, for example, we have this mapping file that is basically a tab-delimited file that just has sequence of characters mapping to sequence of other characters. And so those are actually being treated as the same. There's a patch that is sitting on Lucene right now for this component. And then there's a little bit of documentation, and there's a reference implementation of the Russian stammer. So in case you're interested, it's in the patch stage right now. I found it useful to also extend the existing stammers. So like if an existing stammer doesn't handle like specific corner case, you can actually really quickly append it with this character mapper stammer extension, if you will. In all this work, we also found that it's very actually necessary to start doing testing before we even go into a market and like try to understand like, okay, how well or how badly we can do. And so what we've started doing is like we started collecting this huge data set of like queries and titles. And it's all done by the people that actually trained linguists. So the issue here is like how do you connect our system that we want to be unit tested constantly to what linguist specialist can actually do, right? And so we found a solution that allows us to use Google Spreadsheets, where people would just enter, or linguists and QA personnel would enter queries, match them against some titles, and say, okay, for such and such title, this query is expected to retrieve result. And by creating large coverage of these cases for like titles and people and genres, we want to make sure like we can actually catch some of these cases early before even going in. And then of course we monitor the zero results queries after we launch and so on. But we also use the system for regression testing. So like for Solr upgrades, or like if we make modification to like tokenization pipeline, we rerun it through the query testing framework. So right now we have about 20,000 queries and 7,000 titles. And here's an example. I wasn't planning to go through like a full tutorial, but this is, if you're interested, there's reference to the tutorial itself, how to use it. But it would look something like this. There's a bunch of titles with some queries. And then after you run this plugin or module, it will actually produce reports where it will show you like what kind of queries have failed, and it also will show you the differences between what was run before and after the fix. So you can have an idea like, oh, I just fixed my ASCII folding bug, but I broke a bunch of other stuff. And then it also produces some basic metrics like precision recall, F measure, and it also gives you like by category what kind of queries failed. So in this case, we just like used the Swedish video of regular versus misspelled queries example. I think I'm going too fast. So there's a lot of stuff to cover, but like I'm happy to go back to the slides if you have any questions. If you'd like me to ask it, we can go back and discuss some of these. We have some time left. But basically, what I wanted to communicate is like the autocomplete with these short fields, title fields, is really a special case because configuration needs to consider that, especially like Ngrams is really important for that. But then also the scoring is, and so sometimes you kind of like leave the scoring till the last minute and then like start seeing some unexpected rankings. So you may want to reopen your scoring component and understand why it returns the scores it does. And then we talked about language challenges, and then we'll talk about a couple of these custom components. So just opening for the questions.
Is that spreadsheet connected to Solr?
Oh, no, so the question was, is the spreadsheet connected to Solr? No, it's completely independent. So like the tutorial explains how to like go to Google API and just create a new spreadsheet. And then you point to that spreadsheet from your like query testing framework. And then you point to your Solr instance, and it will actually test it for you. Mm-hmm. Yeah, please.
You mentioned stoppers, but I didn't see a stopper filter in your analyzer stack. Are you actually filtering them out or not?
Actually, yeah. So for that small example, I didn't include that. Right now we don't include it for most languages. We include it for a couple of languages, but most of the time we don't, because for the autocomplete it actually can hurt pretty significantly. Yes?
For the testing framework, are you providing the ability for some queries to be more important than others?
More?
More important?
Oh, more important? So, yeah, so the question was whether we consider some queries more important than others, like volume-based weighting of like when we get the scores, right? So at this stage, we don't, right? So we have other metrics that will measure like click-through rates and playthrough rates, but like at this stage, what we're trying to do is like we're trying to understand lexically, regardless of popularity of the entity, how well we'll do. Yes?
Do you rely all on open source analyzers, or do you also employ some commercial analyzers to handle language-specific issues like compounding, things like that?
So we have not used any commercial analyzers at this point. It's all open source, yeah. Oh, so the question was like whether we're using out-of-box stemming,
are you guys basically like
or
making your own stemming changes, and are you releasing stemming changes if you are?
so like with stemming, we have stemming for some languages that are out-of-the-box Solr stammers. But then we write extensions using this character mapping component that we trying to open source, basically. But the patch is available. You can actually start using that. Yeah, over there.
Are you combining this Ngrams with phonetic search? Does it sound like queries as well?
Like phonetics, phonetic search, like,
Sound like,
yeah. No, so like at the moment we don't. There's a little bit of, so for some languages, for like Arabic language, what we use is there's very wide variations in how people pronounce foreign movie titles in different geographical areas. So you almost have to provide some flexibility there. And so when we did Arabic language, we actually ended up doing, with this character mapper, we actually mapped a whole bunch of different combination of sounds that should be equivalent. And so we do that for like few languages, but we don't do like out-of-box Solr thing. And so in addition to that, we also have spell correction click models that actually use the user behavior on a web and then figure out like what's the query extension could be. Yes?
Did you explain about autocomplete? If the user starts mistyping, you help with that?
Yeah, so like the question was about the misspelled queries, essentially. Like how do we correct for that?
Yeah,
As they're typing, yeah. So because it's kind of like instant search, we have some tests right now that are going on that have this spell correction models. And so like as user typing, we do some expansions behind the scenes and actually integrate the results to show to the user. Mm-hmm. Yes, Tom.
Along that lines, for languages where somebody's using an input method editor, there's a whole different kind of spelling mistakes that are typically made with like an English keyboard.
Yeah.
Are you doing anything to try and catch those?
So like we have a few tests going on right now on that one, but like nothing that that we have in Solr. Yeah. Yep. Oh.
Do you try to auto-detect the language? Or are you force the user to select language beforehand?
It's kind of like a mix. It's a mix. We have when we can detect the language with 100% certainty, we will do that. But in all the other cases, we actually rely on user profile.
It sounds almost like it'd be like a whack-a-mole situation where it's like fixing one language and then breaking another.
Right. Yeah. So we're like there's few languages where you can actually detect it with like really high probability because they have like completely different Unicode range, and so we do that for those. But like in other cases, it can actually hurt more, like you said. Yes.
Are all your different languages in the same collection, or do you have language-specific collections?
So good question. The question was like whether we keep the languages in the same collection or different collections. So all our languages are in the same collection, but the different fields, right? So it will be field per language. All right. Any other questions? All right. Thank you so much. Thanks, guys.